Welcome everyone. In this video lecture, we will solve a problem based on operational amplifier and it is from Microelectronics circuits book. Okay, so the question is for the circuit shown below, the circuit is given here. Basically, it is a inverting operational amplifier, inverting amplifier. So we have to determine the value of V1, that is this point, that is our V1. Okay, V1, I1, this current, I2, V naught output voltage, IL, the current in the load, IL, and I naught. In addition to that, we have to determine the voltage gain, V naught by VI, current gain, IL by I1, okay, and power gain, okay. And this op amp is ideal one. We are assuming that the op amp is a ideal one, ideal, okay. So from this one is our inverting amplifier. So from the virtual current concept, the V1 value, as I'm writing, the V1 value is just nothing but simply 0 volt because this one is at 0 potential 0 volt. So this value will be same as that of V1. Okay, due to virtual ground concept. Virtual ground. Okay, the first part over. Now we have to find out the current I1 in this. Okay, so the second thing means basically this one is the resistance. Now we have to find the current I1 and this one is 1 kilo ohm. Okay, and this one is 0 volt. We can say V1 is now 0 volt and this potential will be 1 volt. So make it 1 volt. Okay, so the I1 current is simply higher potential 1 minus 0 by 1 kilo ohm. 1 kilo ohm. Okay, or one can also write if means if this one I am saying this one is a VI, so VI minus V1 by 1 kilo ohm. Okay, 1 kilo ohm. So which is nothing but simply 1 by 1 kilo means 1 milliampere. Okay, so the I1 current will be our 1 milliampere. Okay, so the very first thing, the V1 value 0 because this one is a virtual ground due to this, and I1 is 1 milliampere. So I have taken this one 1 kilo ohm. This is 1 volt, 0 volt. So I1 1 minus 0 by 1. Okay, or VI minus. Okay, so now I1 is also known to us. Now this current will be 0 due to very high input impedance. The current will be 0. So I1 is same as that of I2 is same as that of I1. So the I2 value is nothing but simply I1, that is our 1 milliampere. Okay, so no need to solve. I2 equals to, now we have to find V naught. Okay, so how we will find the V naught? So to find the value of V naught, now we have to find the value of V naught. Okay, so what I am doing, I am taking this resistor here. Okay, this voltage is our V naught and this one can say this is our V1, that is our 0 volt, 0 volt, and this one is V naught, so make it V naught, and this one is our 10 kilo ohm, and the current in this resistor will be simply our I2. So the I2 value is nothing but simply V1 minus V naught by 10 kilo ohm. So V1 is 0, so make it 0 minus V naught by 10 kilo ohm, and I2 is known to us. I2 is same as that of I1, that is our 1 milliampere. So I am writing here 1 milliampere. So V naught is simply minus 1 milliampere into 10 kilo ohm. Okay, so this kilo and milli 10 to the minus 3 and 10 to the 3 will be cancelled. So V naught equals to minus 10 volt. Okay, so I am highlighting this one. Here I2 I1, okay, and we have find the value of V naught by using this resistor. Okay, this is the process, means I2, then we can find. Okay, so now I2 is also known to us. I2 is already known. Now V naught is already. Now we have to find the IL value. Okay, so for IL what we can do for IL? Now we have to, I am writing here, we have to find, okay, IL we have to find, IL, the current in the load. Okay, for this purpose what I am doing, I am making a resistor. This voltage is V0 and this one is ground, so this one is 0 volt simply, and this one is nothing but simply our IL current, and this one is 1 kilo ohm. So again, what we can write, IL equals to V0 minus 0 by 1 kilo ohm. Now V0 is known to us. V0 we have already find what is the potential voltage here, minus 10. So simply write minus 10 by 1 into 10 to the power 3. So it should be minus 10 milliampere. Okay. So the IL value is now minus 10 milliampere. So here it is shown like this. So current is basically going upward. So it is coming IL minus 10 milliampere. So I am again highlighting this one. Very important digit. IL. IL also we have find out. Okay. So next I naught we have to find. I naught means this current. Okay. So this current, what is the value of I naught? Okay. So for I naught, now we have to find the I naught value. Okay. So for I naught, what we have to do? I naught. Okay. So I am saying this point is A. So just apply Kirchhoff's current law at point A. This current is coming I naught. This current is IL, and one more current, that is our, this current is simply I2. Make it I2. Okay. So use Kirchhoff's current law. Okay. Kirchhoff's current law, KCL. By applying KCL, what we can write? Incoming current means I naught plus I2 is same as that of IL. So we have to find I naught. So I naught equals to IL minus I2. IL we have already find minus 10 milliampere. So minus 10 milli. And I2 we have I1 equals to I2, which is minus 1 milli. So minus 11 milliampere we can say. So the I naught value will be simply writing here. I naught will be minus 11 milliampere. Okay. So this is the I naught value. Okay. Next. Okay, I naught. Now we have to find the voltage gain. So voltage gain is easy. Voltage gain. So basically this is inverting amplifier. So V naught by Vi is nothing but simply minus R2 by R1. Okay. So basically this one is our R2, or I can say this is R1. So 10K by 1. So minus 10K by 1K. So it should be simply minus 10. So the value of V naught by Vi, V naught by Vi simply minus 10. Okay, unitless quantity. So this one is our voltage gain. Okay, so I am again writing this one is our voltage gain. Okay, so we have find the voltage gain. Now we have to find the current gain. Current gain IL by I1. Current gain. I naught by IL. Okay, means current gain. So I naught value is, okay, better to write a small I naught by a small IL, because we are using the notation I, sorry, IL by I1, not, okay. Okay, wait. Current gain, once again I have to check, means what they are asking. IL by I1. Current gain, that is our IL by I1. So we have already find the value of IL and I1 is known to us. IL value is minus 10 milliampere. So that is minus 10 and I1 is already find 1 milliampere. Okay, 1 milliampere. So 1 milliampere. So this milli minus 10. So the value of IL by I1 is minus 10. Okay, IL by I1 is also minus 10. This is an important result. So maybe current gain. Okay, now we have to find the power gain. Okay, the last one is our power gain. Power gain. Okay, the last point is our power gain. P naught by Pi. P naught by Pi. We have to find. So P naught is nothing but simply output power V naught into IL. Okay, and input power Vi into I of 1. Okay, so V naught by Vy, power gain means voltage gain into current gain basically. Okay, so this should be minus 10 into minus 10. V naught by Vi is there, minus 10, IL by I1. Okay, it is simply 100. Okay, so P naught by Pi, if voltage gain and current gain is there, just multiply, it will give of 100. So the final result will be power gain, our final one. This one will be simply okay. So this is all about this question. This is simple question. So you have to use the concept of Kirchhoff's voltage law, current law. So this is all about this question, and this is from the microelectronics circuit book. So thank you for watching this video.